HVAC 360 is brought to you today by Boiler Room Films. Hey, everybody, we want you to meet two of our new superheroes from our upcoming film, The Construction Never Ends Game. First off, we're going to meet the guy they just call the welder. Here he is.
Yeah, so I can weld steel pipes with my hands when I touch my fingertips together. Voila! A perfectly welded seam in seconds. Unfortunately, I got some pretty small hands, so we're not talking big pipe here. And I'm still working on welding plastic pipes. They get all gooey. A little bit too much juice, you know.
Next up, we have the man they call Mr. Treatment.
Yes, my power is using my sense of taste. I can tell exactly what your chemical treatment program needs. Not only that, but I can also produce these chemicals and add them into your system. In wee amounts, if you get my drift. Never have to worry about scale corrosion or biologicals again with me on the project.
Look for the premiere of The Construction Never Ends Game, coming to you later this summer.
Hey everybody, welcome back. Matt Nelson here, your host for the HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week, I'm either sharing information and lessons learned from the field or talking with industry experts. But I don't stop there. I want to encourage you to double down on your weekly helping of HVAC knowledge by hopping on over to HVAC360.com and joining my growing community of people just like you. All right, so what do we got for this week? We got a little paper shuffling in the background, so apologize ahead of time. But this week we're going to talk about the ASHRAE Webcast. Now, they did a little bit differently this year. I don't like the changes, but I know that at least they have the webcast up and ready for anybody who wants to watch it now. I guess my biggest bone to pick with them is that there was no kind of you either had to be there to get the credits or nothing. So there was no kind of replay. They kind of changed that format a little bit, so they didn't have a replay available to ask questions and get that done. So, but of all things being equal, it's still worth the watch, and I'll put that link in the show notes for the YouTube video. You just look for ASHRAE video, and you can actually on YouTube, and you can find it pretty easily. But I'll list it in the show notes as well. So, but for those of you who don't have the 2 hours to spend, I'm going to try to condense what I learned in the webcast for you. All right. So, first off, they started talking about, and again, this is the title of this was Future of Refrigerants, and they were talking about unitary pieces of equipment and VRF systems. But, it really could apply to just about anything because they were talking about refrigerants in general, not just unitary pieces. So the one thing that I guess you want to understand is that a lot of the regulation and policy issues centered around the fact that refrigerants, they have an impact to the ozone. Everybody's pretty much gotten a handle on the other variables of that, but the GWP was the big one that people wanted to reduce. Now, specifically refrigerants, there's a couple of things that they want refrigerants to be. They want to find quality refrigerants. They want to have them perform safely. Obviously, they want to have it to perform well and have that energy efficiency. So those are kind of some of the qualities they look for in a refrigerant. But the GWP is, if you don't understand that, is how it compares to, that's the global warming potential, and how it compares to CO2. CO2 is the baseline, so that's your kind of your zero mark. And essentially what it is infrared absorption. How much heat, is it better or worse than CO2? Does it absorb more heat and keep heat longer than CO2 does? So something that I guess you have to get reminded of from time to time. Now, I guess there is a balancing act between the refrigerant qualities and the potential system inefficiencies, and this is really what you want. There's inherently, when we're moving away from the refrigerants that we used to use, those were pretty good efficiencies. They had a lot of benefits, and we're just trying to get back to where we were with those. We're not going to do it, but we're going to get close, and that's kind of what these future refrigerants that they talk about are all about. Now, I guess the three sort of regulatory pieces of information that you want to be aware of, obviously there's the Montreal Protocol, the Kyoto Protocol, and the Kigali Amendment. That was a new one that I learned during the webcast. Now, the Montreal Protocol is one that we have adopted here in the U.S. and adopted, a lot of different places. But that is set to be complete by 2030. So just kind of keeping an eye on exactly when things are supposed to be all done. 2030 is that deadline. Now, the Kyoto Protocol wasn't ratified here in the U.S., but and either was the Kigali Amendment. But the Kigali Amendment actually was an amendment to the Montreal Protocol just to kind of update things. Now, the EU has come up with their own set of updates, trying to get some regulation on the books, and this is what they call the F-gas regulations, and it started about 2018. So if you want to learn more about that, just take a look at F-gas regulations in the EU. All right, now obviously when some of the original refrigerants, they wanted to get rid of the chlorine because the chlorine molecule that was the CFCs and the HCFCs. Those were what they wanted to get rid of, and that was kind of the first big hurdle. So they settled on now the HFCs. So when they're trying to get from the HCFCs to the HFCs, now that HCFC that they typically were referencing was R22, just so you know. But the HFCs, and the F is for the fluorine molecule, there's a number of them that they had different options for. So going from R22 to a more standardized HFC, they were looking at 404A, which tended to be less efficient. It didn't have the coefficient of performance of COP. That got reduced quite a bit. 407C had some issues with glide, and we'll talk a little bit about glide later. R32, again, a single molecule, that is flammable. So that was kind of put on the back burner, so to speak. And the one that they ended up pretty much focusing on was R410A. That had less glide than 407C, and but it did have slightly higher pressures that you're going to have to deal with. Now that's interesting because if you've been kind of in the industry for long enough to see the transition, the migration from the R22 to some of these others, you did see a 407C, you did see 410A, but now it's kind of all 410A, just because of the properties. And you're gonna say, and the results are going to be that you're going to end up seeing some of these multiple refrigerants being used by different manufacturers going forward, because they're trying to settle on different refrigerants, and there's no clear-cut winner, so to speak, right now. When taking a look at the U.S. consumption, the vast majority of the dominant new unit is that 410A. R22 is still around. Now, if you look to Europe and other places, R32, remember that was flammable. That is in 50% of the new equipment in 2019. So that's gaining market share. And I guess that's one of the things that was a common theme, the flammability. That you're going to end up seeing refrigerants that are more flammable. Now, the one thing that was very interesting, and it was because of the 410A. I never really realized. I knew it was a blend, but I didn't know necessarily a blend of what. I didn't really have I wasn't really, interested in, getting down to the nitty gritty there. But it turns out that the 410A blend is actually a blend. It's a 50% blend of R32 and R125. Now, you might say to me, Matt, R32 is flammable, but I know that 410A is not flammable. It's still a 1A gas. What's up with that? Well, let me explain. The reason they added the R125 is because it's more of a flame-resistant molecule. So when you blend the two together in that 50-50 blend, the whole refrigerant becomes not flammable. So that was the one bonus of the 125. Anyway, so let's get into this range, the glide they talk about. So when they talk about glide, they're talking about the blend of the refrigerant. The blend is, since different refrigerants obviously have different properties, when you put them together, that doesn't change. They'll still have maybe a kind of a uniform behavior, but one of the things that they do is they still they change phase at different. They boil off at different points. So you're going to have a range where some start to boil, and then the others, it's going to be a different temperature that's going to boil. And that difference of temperature between the two boiling points, that's called the glide. And the smaller, really, realistically, the smaller the better, because you're going to have impacts on, what you're going to calculate as far as your approach temperature is to the coil, and setting in the way you set the coil up. And also there is issues with maintenance and leaks, and we'll get into that a little bit later. So the smaller the range, the smaller the glide, the better. Typically, if you're looking at a glide of like 3 degrees, that's pretty good. Some of the refrigerants that they were looking at, as far as replacements, were up in the 7.5 or the 7 to 9 range, and it's still acceptable, but obviously there are just some other things that you have to keep in mind. All right, now the one thing, obviously, when we're talking about the chlorine molecule with the CFCs and the HCFCs, that they were looking at phasing out the refrigerants. They were looking at stopping production on R11, R12. And they didn't want even R22. They're gonna want to phase that out. But the HFCs are going to have a phase down. So they're looking to transition, but they're not looking to totally stop the production of the HFCs. So 410A is going to be around. They just want to minimize and try to transition to a lower GWP to be able to satisfy that. I mean, they're ultimately looking at getting down to a GWP of 300 or less. And just as a comparison, R11 and R12 had in the tens of thousands. That was their GWP. So we're much better off with some of these new refrigerants, even at the minor inefficiencies that we do get hit with. So the one thing that they had questions during the webinar. One of the questions says, should I keep my R22 equipment until final refrigerants are available? Understanding that the question really understood that what we're going to see here is we're going to see a transition from, we saw the transition from R22 to 410A, and we're going to see another transition to some other refrigerants, but ultimately we're going to get to refrigerants that we're going to end up using for a long time, that, we've pretty much settled on. I don't think that there's going to be improvements beyond that. There could, but the kind of the vibe from the webcast was ultimately there's going to be, around 2028, we're going to have some final refrigerants. And, that's going to be up to, the refrigerant manufacturers and the unit manufacturers to figure out exactly what that would be. Curiously enough, that there was announcement that residential equipment efficiencies are going to be changing around 2023. So there's going to be a shakeup in another 4 years or so with the efficiencies there, and that's gonna play into what ends up ultimately happening with the refrigerants. And since the residential market is a large portion of what we're talking about, that's what we'll focus on. So now they split the webinar up into two different sections. They looked at lower 410A alternates, and they looked at the lower GWPs for the 410A alternates, and also then they took a look at the under 300, the GWPs under 300. Now, what you need to know here is that the alternates to 410A, and here's where we get these kind of the staggered. It's not going to be a final change from 410A. Any of the alternates that are around and alternates to the 410A refrigerant, they couldn't get. Some of the lowest GWPs were around 450. So currently, what they're looking at, they'll improve the 410A. And they're really looking at coming up with and focusing on one of those refrigerants, but then they're going to have to make another transition away from that. And again, excuse me, the one thing that they did say is that, why not come up with a completely new molecule? I mean, why not focus on somewhere else? And realistically, they said that there's a limited number of molecules that work well with refrigerant or work well as a refrigerant, and the fact that you're going to end up having a blend because you want to have certain properties in a refrigerant. So you're going to have you're going to end up with a blend of some variety. So that's and the change why they don't want to go. Just kind of reinvent the wheel, is they already have equipment that is set up for a certain refrigerant. So if you change all the properties about it, then it's going to be very impactful to all the equipment manufacturers. They don't want to make that big of change at just one time. Now, there is going to be a big change because, again, like I said before, the future of refrigerants, where they're going is they're going to go with a more flammable refrigerant. But there's only, I think, if you talk about the other 410A alternates, there's 466A is the only one of those that really is non-flammable. All the rest have larger portions of that R32 molecule, again, which is flammable. When we look at the under 300 GWPs, and you really are, these are more of the high glide type blends. They have different molecules, but they're not, they have these different boiling points for them. So you have the wider glide. And I guess the thing that's important to realize about these glides, you talk about maintenance, you talk about leaks. So what is that? Because if there's a leak in the system and you don't know what boils off when, you have to fix the leak, take the charge out, or take the charge out, fix the leak, and then you have to charge the system with a completely new charge of the refrigerant. You don't know because it's going to the ratio of the different blends is going to leak out at a different rate, and you don't know. There's no way to necessarily test that for sure, and then just pump in new. You just have the refrigerant, the bottle of refrigerant, so you really need to draw everything out, recover that, get it recycled, and then put the new refrigerant into your system. So you just can't top it off. And the one thing that they also stressed is that unlike some of the when they tested and compared different refrigerants, they used them in a kind of a drop-in type of they used them as like a drop-in. And what I mean by that is that, say a machine was set up for R410A, and they took that R410A and they put different refrigerants that they wanted to compare the performance to, and they put that into the same machine. Now, obviously, this is in a lab environment. They definitely know what they were doing, but this is something that can be extremely dangerous, especially when you're dealing with flammable refrigerants. This is some of the most dangerous things that you run into. So dropping in some of these new refrigerants to an older machine, it's just going to be a no-go. It's a non-starter because of the flammability and the different things, the different safeties that they're going to have associated with the new equipment, with the new refrigerant. All right. Curiously enough, the question did come up. Hey, what about CO2? CO2 is as a refrigerant. It's been around for a long, long time, and why is that not going to be the go-to? Because the GWP there is it's zero. It is the standard. But the interesting part, and I never really understood this, because I've seen it being used in some new projects, but the CO2 basically it's very low efficiency. It's not very efficient. And what how you can get away with that is that they are in industries where this minimum energy efficiency standards is not there. So when you're dealing with like coolers and things like that, it's just not there as far as supermarket coolers. The energy efficiency standards aren't there. But for the other residential standards, there are efficiency standards, and CO2 is not anywhere near what these refrigerant blends that they have now or that they're going to have in the future. It's just not the same. And one of the problems with CO2, I guess, is it doesn't to get it, it doesn't condense. So it's always kind of a gas for the most part. And I'm going to stop there because I am not an expert in CO2. We could probably have somebody on that does a little bit more than that. So some of the product risks. They talked about factory charging. That's going to be a low risk. They're going to have transportation and storage of these new systems and these new flammable refrigerants. That's going to be a pretty low risk. The operation of the equipment, that's going to be a low risk as well. Where you get high risk is you get the installation, service, recovery, and decommissioning of systems. Because that is where, obviously, an errant spark could set things off. So there's definitely going to be more training involved, as far as the technicians out there that go, the maintenance people, they're going to have to understand exactly what to focus on, what to do, and the different procedures that they're going to have to learn. Now, with the standard, the 410 or the 410A, that's a non-flammable A1 type refrigerant. That they focus on the oxygen depletion limit. So when you're talking about putting those, especially with VRF systems, and you're talking about space, and you're talking about, what are some of the concerns there? And it's really the depletion of oxygen and suffocation. With the different refrigerants, talking about the A2L and the A3, they are going to be size limited because even though they do have an oxygen, an ODL, an oxygen depletion limit, that's not going to be the primary driver. That's not going to be the focus. You're going to end up having additional systems in there that really detect leaks. You're going to have some sort of circulation or ventilation that dilutes the leak. and you're going to have a way to shut off the refrigerant, to be able to isolate it and to be able to minimize the amount of refrigerant lost. So kind of like gas piping, you're going to have some sort of shut-off valve. And that's just going to be a few of these. There's going to be a whole different policy and procedures that are going to take place. So when you start to get these new refrigerants, these new flammable refrigerants, just don't assume that it's just like, going from R22 to 410A or 407C or whatever you have. You're going to have to focus on designing it correctly. Ultimately, what this leads to is it leads to smaller sizes. They're going to have smaller units, less than 3 tons, that kind of thing. So that's really what they want to focus on. They did mention in some of the Q&As, they did mention a couple of things. They did mention propane. That's R290 if you're scoring at home. And again, this can be used but in smaller limits. And again, window units, dehumidification units, or possibly larger exterior systems. Again, if you get it outside, and that's kind of what you're really looking into. If you're getting it outside, then you can you have different things that different rules that you're going to have to follow. It's not going to be so restrictive. And they also talked about ammonia out there. And again, that has been used for a long, long time, but usually in more of a larger industrial commercial refrigeration applications. So let's see. Ultimately, the what they kind of resulted in, and what the results were is, yes, it's going to be more flammable. There's going to be different things that you're going to have to learn about, as far as engineers, about technicians, as far as how to handle it, how to design it, and you could see more heat exchangers. So heat exchangers taking using a primary loop of the refrigerant outside, and then taking a secondary loop using a heat exchanger and taking that secondary loop inside. You could use basically smaller groups. So you're going to have more of a distributed type of system rather than a more of a centralized system. So that's some of the things that you can say. Also using chillers, air-cooled chillers on the outside. That's going to be something that you might see a little bit more of. All right, so that is my, condensed half hour of the 2-hour program. If any of those things were a little bit confusing to you, go ahead and watch it on YouTube. It's not that bad. If you want to hear the experts instead of my kind of rehash of it, but that's really the important things that you need to know. Nothing's set in stone yet, and just keep an eye on what's coming out in the future. So, having said that, I appreciate you, and thanks so much for listening. I hope this was helpful. If you know somebody who's looking for more information about this, consider passing the episode along. I mean, that really does help broaden the listener base, and you're doing me a huge favor. If you're not a subscriber, consider joining the growing community of people just like you over at HVAC360.com for more weekly goodness. And lastly, I'd be greatly honored if you'd consider leaving me a rating on Apple Podcasts. Also, as a note, if you could go ahead and go to my YouTube channel at HVAC360 and subscribe there as well, even though if you are a listener of the podcast on your podcast app, that would be greatly helpful to me. All right, well, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.